thank you all for coming. And I've not spoken in public for a very long time, so thank you. And please stop me if I just mumble. So talk today is fun and profit with Linux EDR. And I'm going to speak about something I've done recently, and I'm just going to go through that. Just put those aside. Okay, so let's just start. So just quickly about me. TLDR, father, husband, red teamer in Israeli. So I was born in Israel. I lived in Israel most of my life. I moved here about 8 years ago. And been working in the UK in security ever since. I'm part of Mandiant, which is the leading incident response company in the world. Recently been acquired by Google, as Steve said. We're very much still our own thing. And we have a very big consulting team. So I'm part of the APT 66. It's our own internal red team name, which is part of the Europe red team. So we're all one big team of red teamers in Europe. But we have teams all over the world. Our Europe team is APT 66. What else? I've been as a security for 7 years, a pen tester for 4 years, and red teamer in the last 3, being manager in Big 4, in other small companies doing that. Some accreditation, the boring stuff, CRTO, the 0-point security, CREST. Don't even get me started about CREST, but if you know, you know. Doing CCT and process of doing CSAS, which is the attack simulated specialist. Handle on Twitter is New Era. You also have a GitHub repo with, if you know both of the things, sharp all the things, just collection of tools together in the same thing. And I also have a new repo, which I'm going to talk about first time in these slides. If you want, I also have a Notion site. It's down there where I'll upload a lot of my notes. So if you're getting into security and you want to know how to perform information like infrastructure testing, red teaming, web application testing, mobile testing, I have a lot of notes on those on my Notion site. It's a good place to look at if you want to look how to do anything. Served in the military as well, as I'm Israeli, 3 years in the military. And I haven't been to uni, so everything I learned was from the job or from trainings I've done. Sorry for the people going to uni. And the last thing is I'm jack of all trades. I do not specialize in a specific thing. I like to learn everything and anything. I'm a big Twitter addict, so I read a lot about Twitter. I read a lot of things about Twitter, about InfoSec, so I'm very much up to date with the latest topics and latest exploits. One of the 3CX is the thing you talk why people are not here? The supply chain tech, never mind, sorry, just mumble. Last thing I have to say, English is not my first language. It's a very stressing environment to speak in public, so sorry if I mumble, sorry if things doesn't come out properly. Please stop me, please ask questions at any point, it's okay. For me, let's make it more casual and more fun because I don't like to be too official, so you see t-shirt, jeans, that's how I roll. Yeah, so let's start. So how many of you been thinking, okay, Linux, that's easy to bypass, just run Metasploit, just do that, you get a shell, you get everything, that's fine. Like most people do not care about Linux incidents. Okay, let's start. EDR is incident response and detection. It's not very much a thing in Linux environments. So people are like, okay, I get a shell on the server, it's all good, I can do everything, run everything from there. What happens when you actually land on the server with EDR? What can you do, what you can do, how to bypass them? That's what we're going to speak about here. So let's start with some background, what we should do, what is the goal of this environment. So our goal is we are on the purple team engagement. We're doing a Zoom breach, so you're already getting SSH credentials to log into a thing. It's 2 weeks, 2 weeks to do everything you want. How do you do that? The client hires us to do as external contractor, and that's why we got a Zoom breach, and that's why we get SSH credentials. We get 2 hosts. Each one of the hosts have a different EDR, different antivirus. Let's see if we can bypass them or can bypass them. Also worth to know, the OS that they're giving us was old OS, so kernel, CentOS kernel 3.7, I think it's about 5 years old. Only Python 2.7, no Python, as you know, is deprecated, so nobody uses it anymore. Well, everybody uses it, but nobody else out to use it. And I said, I wrote 3.10, but okay, it's 3.10, sorry. Our goal is to defend security issues and move laterally. Okay, we're getting on the server. What command and control do we use? Quite obvious ones for, I guess, for Dig is Mythic and Sliver. When you think about Mythic, if you know it's a command and control, they have multiple agents in multiple languages. It's getting a bit difficult of like, well, which language should we use for each one, or is it actually good because it's self-developed? Things we can't use is our own internal C2 because it's a purple team, so we have to stay stealth as possible. We can use CobbleStrike, the most well-known C2 in the world, because it doesn't support Linux. So our considerations are cross-compile, so we can compile into like multiple operation systems, and to make sure, now it starts saying, why are we native? Okay, it's run natively on the system. And obviously we have to make sure all our communication is encrypted. We don't deliver anything in clear text. What do you use? What do you think will be good for this one? Mythic, okay. That's a really good choice, but I decided to go with Sliver. Sliver is by Bishop Fox. He created their own C2. It supports communications in DNS, MTLS, which is mutual TLS, WireGuard, and HTTP and HTTPS. Even if you choose HTTP, it's still encrypted because they're using their own class of encryptions. And they have two types of beacons. They have a beacon and a session, which beacon does periodically checks, which basically like CobbleStrike, check every 30 seconds, every 10 seconds. It just set up the sleep time. Or long polling, which is HTTP connections, which always run. It does issue a command, and it waits until it grabs it, and there's no beaconing. So sessions are much more safe, which does long polling, because it doesn't create that anomaly of a beacon every so often. So it's a bit more OPSEC secure. In terms of obfuscation, also Sliver does obfuscation by default using Garble. So it's written in Go. So all the authentication, encryption is done and obfuscated using Grubble in the background. So you don't need to apply anything else on top of it because each binary will look different. It's well maintained and it's also well abused by APT actors. As you can see here, this is a page from Mandiant intelligence page, which you can see where malware is associated with, threat actors are abusing it, their capabilities. It's just like well abused, well used in the world. But it's a really good C2. It's very advanced. It's very good at what it does. Okay, so game day. We're going to start the engagement. Obviously, our attack surface is a bit smaller because it's Linux. It's not Windows. Everybody bypassing Windows machines, but not many people talking about how to bypass Linux machines. There's less injection methods. There's less things to abuse. Okay, so we start. We issue a Sliver command to generate. I put this image in the wrong place. So we issued Sliver to build a new payload using the -e parameter. So it does invasion. We tell him the server we want it to communicate to, and our operation system we're going to target is Linux host. It generates a new binary, but the binary is 15 meg. That's annoying. We've not done any other obfuscation except the native Grubble that it does it. You can see here that the binary itself is 15 meg. In the format is ELF64, so it should run quite natively on the operation systems. And that's the quick question. So we have two hosts, two different EDRs. Do you think that bypassed any of those EDRs? Was it detected or not detected? No, both of them caught this binary. Okay, good start for EDR, 102 EDR. And then, okay, let's try something else. Instead of an ELF, which is similar to EXE, let's do a shared binary, which is more a DLL type of format. It's the equivalent in Linux for DLL, shared library. We generate a payload, again, keeping the same formats, but this time putting a shared, which is a DLL, of course, and let's see what happens. Okay, now the binary is even bigger. Doesn't really matter, to be honest. The size these days, internet speed is quite high, so it doesn't really matter a lot. But still, we can see here it's an ELF, but it is a dynamically linked, so it's a shared library. It does grabble. Is that enough to bypass EDRs? What do you think? I'm going to keep it for the next 3 slides. The what do you think? Bypass or didn't bypass? No? One of them didn't bypass. One bypassed. So that's all we had to do. Just change the type of the payload, and then bypass the EDR. Great. Good start. Okay, let's do it again. This time, we take the same binary, but we pack it using UPX, which is a well-known packer, which is very well abused by threat actors. What a packer does is shrink the binary, remove symbols, remove stuff that might be, could generate more RFCs and could be detected by EDRs. So we pack it this time. It does the native obfuscation using garble, didn't spell it right. And so from a 17 meg shared library, now we got a 9.8. So what, about 40% of it is gone. And this is how we ran it. -9 is we choose to compress it better rather than faster. So -1 will be faster, while -9 will be better compression. Yeah, we done that. Would that bypass EDR now? So what do you think? Second EDR, would it bypass or not? Yes or no? Yes? Is that all it takes to bypass EDRs? Probably, in most cases, but not in our cases. I'm not going to mention EDR names. It's a public talk. Don't like to offend anybody. So I'll keep it as very vague as that. Okay, going up next thing. Let's try add more things to it. Let's see if it get detected. So this thing, still keeping with the shared library, automated application by Garble, packed by UPX, but now we're adding a GTFO, which forgot what's the GTFO thing. It's the equivalent of Lobus. What Lobus is it's a website which you can find information about Windows systems, how you can use native libraries to execute certain things. So stuff like download a file, upload a file, load DLLs. So you look into Lobus, and you can do that in Windows. GTFO is the equivalent in Linux part, where you can see how you can download. You can see all the commands here. So you go there, you choose, I want to run a shell. When you run a command, it will tell you using a known binary how you do that. So we use Python. We look in Python, how can we load up a library? So it's quite simple. We're a short Python one-liner, and we can load a shared library. Is that enough to bypass EDR? What do you think? Is that bypass our EDR now? No? Yes, that's all it took. So a bit of Lobus, a bit of Python. Everybody loves Python. And it's Python 2.7. There's a bit of different syntax for Python 3 if you want. But yeah, so shared library, UPX, that's it. That's all it took. So now we bypass them. Now we can go on our live, do our own actions, our own enumeration, situational awareness, everything. So we're all good. So now we're going to roll back and look at stuff I learned through this and stuff that could help you if you're going to come up against those stuff. One thing I didn't know about when I ran Sliver for the first time is about that parameter over there, -r, which is run on load. What does it mean? It's like change the entry point for the DLL, share library. So it tells it when actually you load the library into memory, then execute it. And if it doesn't add it, it doesn't execute the library. So we'll see here in this part with -r, once we load the shared library into memory, it executed that already. While here, we have to specificate the entry point, which was start W, which is the same thing in DLL, start W. So it's a gotcha, and that's something that I didn't know when I started doing that. So it was something I thought worth mentioning. Another question? Sorry. Yeah. So look how we can now improve this. What else can we do to make our be more stealthy, more OPSEC secure? One thing I've learned about, and I don't know how many people know about it because I didn't know about it, and I thought worth sharing, is something called memfed create, which what it does. How many people heard about the term in everything in Linux is a file? Yeah? I see many nodding heads. Everything in Linux is a file. But then you read this description, which basically says, it is a file, but it's in memory. So is it a file? Like, everything is a file, everything should be related to files on disk. Well, yet this one is fully mapped to memory, is being traced when you delete the RAM. It lives in RAM, it's not backed by any storage. Well, someone lied to me. So what's going on? So let's deep dive into it. So we said everything is a file in Linux, but, well, that's not right. Everything is treated as input and output, and that's why we have standard input, standard output, standard error. Everything is an input and output. So saying everything is file is wrong in the sense of why they created Linux. It's also part of memory. So we can use memfed to create anonymous files, keep everything only in memory and stay evasive. And it's quite easy because all you have to do is pipe it into Python, and it all stay in memory. It's quite good. The problem with this engagement was this is only available from kernel 3.12. We ran 3.10. So it's not very helpful to me, but I hope it's very helpful for you. But stuff I learned for the engagement, this is what I tell you, because hopefully you came across more mature environments, more up-to-date, you can use those stuff. So how does it work? We create an anonymous file using our function. It returns a file descriptor, which is just a bunch of numbers in the process you're running at. And then we can load directly our shellcode into that. It can be ELF, it can be a shell library, whatever you want. You can just do it directly through that. So everything stays in memory. So how can we abuse it? How can a simple man like me abuse this without starting to dig around why it does anything? So this is a few links of tools that to run that and stay only in memory. Again, I'm sorry on this one, but if you're looking. So for the next few parts, I'm going to talk about tools, and I'm going to give links of what they do, so you can all try that at home. So the first one is exactly what we said. Run a simple Python script to load our executable into memory without leaving any traces. As we said, simple car, pipe into Python, and you got a beacon back to yourself. There is the same thing with ELF, where you can just embed your shellcode into that, and you're good to go. And the last thing is how we avoid other system calls that might be detected by common EDRs. So we use this utility, Evasive, which avoid using the execve, which does, in nature, that's what loads the ELF into memory. Okay, I'll stop here again. Any questions before? So that's a few tools you can use. You can bake it into your C2s that quite easily execute stuff in a stealthy way. But as I said, it wasn't very helpful for me. Next thing, okay, let's look. How many people of you heard of cough loaders? So we got a few people. Cough loaders are, cough is a format in Windows where it's a very raw format. So it's Windows files are the original thing, like the most raw format called cough. We use it in C2s to load like C scripts that can execute stuff inside the thread and are very evasive. So that's the premises of BOF. If you ever heard Cobalt Strike BOF, beacon object file, that's the very premises of it. It's called cough loader. It's now baked in every command and control, and it's very, very good to evade telemetry and EDRs. We mostly use that these days. So something I didn't know is the equivalent of the cough loader for Windows. There's one for Linux. It's called elf loader. Simple as that. So again, it's a very evasive method to load files, load scripts into memory without triggering any endpoint detection response tools. And that's all it takes. It's just cough loader, a file, script, which is, if you notice -O, it means it's not compiled. It's a very raw format. And it'll give us output. Obviously, in this case, I ran it from a command line. But if you run it from a C2, it'll do the same. And it's a very evasive method. So that's something good to know. Next thing is, how many of you heard about linpiz? Again, a few hands. It's a privilege escalation utility. It's very famous. Everybody uses it to find privilege escalation methods, so ways to gain more privilege on hosts. And it's very good at what it does. It does a lot of checks about ways you can gain more privileges on a Linux host. One thing I didn't know is you can quite easily tweak it and build it with less IOCs. So one of the biggest IOCs of it is this massive logo. When you run linpiz, it prints a massive logo on the screen. And then it's quite easy to EDR to detect it. It's looking for the ASCIIs. So you can build your own scripts. If you just run this, you can see here, it loads the system information, search for the system information, or it loads containers, searching for container informations, or any cloud. So if you can communicate with metadata or URLs. You can remove one of those and build your own version of linpiz that will evade other memories. Or you just take out what you don't need and only include stuff you do need in it. There's other version of this. Right? So it's quite useful to build your own. And other useful stuff is stuff like static binaries. So if you go to this URL, this guy, very nice of him, about 7 years ago, built a very static binary. So I hope most of you heard about Nmap. A very common utility, very good utility to search for ports, but it has a lot of files in it. It has a lot of files comes in it. This guy statically compiled a version of Nmap that you can just bring into the environment, and you don't need to bring anything else. So you go there, you download the file you want, or you can build your own. There's also a build version. But again, the build he said 7 years ago, 8 years ago, is quite high to that. So I would recommend using your own CI/CD pipeline to create your own. So you can bring that and create port scanners. But you also need to bring up a service, another file if you want to actually, Nmap will scan the ports and tell you if the port open, but it doesn't know what, like it prints you, this is HTTP or this is HTTP based on the port. Well, it doesn't know to do it without bringing another file into the environment. But you can use that, it just is raw format of scanning for ports. It's quite useful because you just don't need to bring anything else except one executable. Other alternative is just create your own port scanner. Probably good ways to use Golang is cross-compiled, and it's really good, really fast. So it's useful to use that. And then we're moving a bit away from technical part, just technical areas, and just looking now at different aspects of Linux EDRs and what you can do. Any questions about the parts we just spoke about? Yep. Probably rushing it, sorry if I do. I will stay obviously later and speak if you don't. So one thing I didn't know, which really surprised me, is EDRs can look into Dockers. So you can see here, we got our attack path of an EDR. If you've seen this dashboard, you'd also know which EDR is it. Of EDR looking into a Docker that I created on the host and detecting the nmap from that. So for me, it was really surprising because I thought, I'm going to be stealthy. I'm going to create my own Docker image, run this on the Linux host, and then I could avoid any detection they have. If they installed any tools, any security operations on the host, I evaded by bringing my own container into it. So that was really surprising for me. And I thought, that's something people should know. We should look into that. So be aware. So I said I can't reveal the EDR's names. But one thing I try to do is my own time and my own experiment is find out what's the names of those processes of other security vendors. So I created a repo, Linux Security Products, where I list the name of the EDR or security product, their process name, and their service name. So now, if you landed on a Linux EDR, you wonder, how can I identify if there's a security product on it? You can just go into the user lib systemd system folder and check for one of those process names, service names. If they're running, you're most likely running against EDR. This is some kind of EDR environment. You know to restrict your movement, you know to be more careful of what you do. I guess it's like in Windows. If you land on a host, the first thing you do is threshold awareness. You check what security products are on it. So it's quite, I couldn't find this information anywhere on the internet. Everybody talking about Windows EDRs and how to detect them or bypass them, but nobody talked about Linux EDRs. So I created this repo. You have a question, sorry? One thing that other people don't know about, which I thought is quite useful, is how many of you heard about MITRE ATT&CK? So again, a lot of people. Do you know there's a MITRE ATT&CK for Linux? It does the same thing for Windows, but the same thing for Linux. It also, I think there is one for enterprise, there's one for OT environments, one for IoT. But I didn't know there's a Linux MITRE ATT&CK. So this is really good. If you want to take your actions you've done and map it into MITRE ATT&CK techniques, you just use this. I didn't know it exists for Linux. I thought it'd be good for other people to know it as well. Okay, so we're almost at the end, don't worry. Idan, I want to practice that at home, how to bypass EDR. What can I do? So a good way to do that is look at free EDRs, free security tools to try and bypass them. So a very well-known antivirus, which is open source, it's called CalmAV, which you can run it. It has a lot of Sigma rules, a lot of YARA rules, and it will scan your binaries, scan all your stuff you do on the host for malicious things. So that's the way you can practice. Elastic does EDR product as well. And you can register for a free trial. It also have AuditBit, which is a log monitoring. You create rules based on AuditBit. Very, very easy to create AuditBit rules. For example, in this engagement, how they caught me really quickly on is they created a rule to detect wget. So when I download my payload from the internet to that host, they're being alerted. So that's a great detection rule because a lot of red teamers, a lot of threat actors who use wget just to get their payload. I'm very impressed with that. As I said, you can also run your Elastic trial and use that. It's really easy to install. It's really good to know. There is also Sysmon for Linux, which again, I didn't know, but it was only released, I think, a year ago. So Sysmon is obviously a security product for Windows initially to detect certain event logs. So they also supported that for Linux, and you can run that to create rules, and you can detect certain actions and use it on Linux. So that's good to know. And the last thing you can use is Azure Sentinel. Create your own lab. It's free. You can use with developer account. You create your own lab. Use that. It's quite easy to build a lab for yourself to test all your products, all your security tools. And if you want to learn even more, take it even a bit further, there is VX Underground. They have great papers on Linux malwares in their techniques. We talk about the second GitHub repo, which is running running shared libraries or executables using memfed, and the other one as well that I didn't remove it from here, so I'm sorry. And that's it. Hope you enjoyed it.